Hey guys, today is the last meeting of the semester. Glad you guys could make it. So my name is Sagnik. I'm a junior in computer engineering, and today I'm going to talk a bit about cloud and whatever current security is going on with regards to infrastructure. So this announcement in this Thursday, we don't really have any meetings coming up, so we might have something a little bit social or any study session for the finals. So please feel free to drop by. And that's the meeting flag and mandatory XKCD comic. I wonder what happens if he trips over. What do you think? It's a lot of connections lost. All right. So to start off, as kind of a general overview, we're gonna kind of split this into two sections. The first one I'm gonna talk about is a couple of very commonly and recently rising technologies in cloud, specifically some cloud-based tool chains that we use, such as Terraform, which is managing API endpoints and automatically to create deployments. And we're also going to learn how to like uncover stuff and original web servers that have been hidden or encrypted by Cloudflare. For the second one, I'm going to talk mainly about deployment pipelines, so CI/CD, and a very recent thing that happened last year with regards to the Rust program with artifact poisoning. So again, whatever I'm going to talk about is very easily used right now in the industry. So there's a don't go to jail slide. It's been said in the beginning of the year. I'm going to end the year off with it, but you're not allowed to access information that isn't allowed to be accessed by you. Mind blowing, right? So even if it's in good faith, you might be held liable for any damages that result from, say, poking around places that you shouldn't be in. So with that, let's start off with exactly what the cloud is. So this is kind of like a basic architecture behind the AWS environment. So if I was, say, a developer, I'd like to very easily host my code and be able to scale with regards to how much like traffic I want to like scale with traffic, for example. So I have like a development environment, I make my codes, and then I say I want to push it to GitHub, which is a very good version control system. Afterwards, I'm going to run a few checks on the code to make sure it doesn't shit the bed. So I'm going to push it through Circle CI, which is a continuous integration platform. I'm going to deploy it to this network and security based like platforms. I'm going to say host it on a Docker container or say Kubernetes. I'm going to try to monitor and log anything that's going on in different traffic. And I'm also going to try to host like different files for S3 so that I can like give different artifacts between my web servers. In the context of what we're talking about, you could kind of consider the cloud. There's obviously a lot more definitions with regards to whatever you're doing, but for now we're going to focus on this thing. So our meeting is going to mainly focus on the CI/CD and version control parts of this. But CloudSec is a very broad topic, so you might go over the other ones. So for modern security tool chains, you want to think about what they use nowadays to automate or scan for bad software and what they use. So to start off, a very now commonly used platform for deploying firewalls, network segmentation, and securing API endpoints is Terraform, which is developed by HashiCorp. So organizations can define and program custom policies to match their business requirements. For example, if I want to like send this package directly to this repository at this time, I could use Terraform to help me do that in a very secure manner. So it handles API keys and other sensitive information. So how do we use Terraform? Terraform is written in the language HCL. So what I'm going to do is initialize a Terraform instance and plan and apply my policy on example.hcl to create and manage a state file. So I'm going to define the infrastructure or like the business logic that I want to do in the Terraform file. And I'll review the changes that Terraform will make to the infrastructure and then apply them to provision different kinds of existing infrastructure. For example, an HCL file snippet would be something like this. For example, if I want to like provide a certain region or a server that my system is operating on, I could say my provider is AWS, which is the manager for the overall hosting infrastructure. And I'm using the US West 2 region to deploy. And then the resource would be this AWS instance. For example, this AMI hash and whatever instance type. We're using an EC2 instance of the tier 2 and micro. So we're able to like automatically spin up an instance that way using Terraform. So this is a more complicated state configuration, the Terraform version and whatnot. So I could actually make a lot of apps this way. So of course, you have to consider stuff like security when transferring different resources. I mean, no brainer, right? So some common threats in the Terraform threat model would be something like an unauthorized access to a resource or some sort of like sensitive information. This can stem from something like a faulty IAM role. So an IAM is simply like identity and access management within like, say, AWS's ecosystem. If I want a specific user to be able to access this resource via Terraform or able to like write new Terraform configurations, I would give that user an identity and access management. So the role kind of specifies what you're allowed to do and what you're not allowed to do. So if I have something like a faulty IAM policy that's automatically deployed, and I'm able to like give roles to other people who might want to work on the Terraform project, we need to be very careful because just letting anyone take roles without like proper enforcement of security protocols can lead to stuff like privilege escalation or a lot of other things. Another thing is that like Terraform is implicitly designed to help you tamper with infrastructure. So this can lead to some unapproved changes or unauthorized deployments. So not properly authorizing artifacts, which are like your ending build packages with dependency. Not properly authorizing artifacts and checking that they're valid can lead to something serious. There's more on that in the CI/CD section. And you can also, mitigating such threats also requires us to follow like a strict set of deployment protocols, such as like rotating keys every once in a while to make sure that you don't accidentally compromise the key by reusing it in the same place. So some security considerations on that would be, say, enabling server-side encryption for state configurations. So I could enable like an encryption protocol on the server side to accept, say, a private key and be able to check that with whatever has been sent from the server. And if like the signature sent from the server does not match, you know something has been tampered or something wrong with that based on the server-side encryption protocol you have given. You can enable state locking to disable concurrent modifications on the state file. So if someone is kind of in the middle and trying to like intercept or modify the file that's not connected to the current build, you can be able to detect that and say, no, I'd rather want this master modification to take precedence. And no one's allowed to like concurrently change the current file. So we know consistently that like a secure development's being made. And we can also ensure permissions are properly dispersed with stuff like IAMs. So AWS has a lot of security policies also in place that you can define if you want to like, say, set up an IAM policy for whoever can modify Terraform. Another thing, you can also add code scanners in the integration phase of whatever you're deploying to like a cloud server. So code scanners are like infrastructure that has been serviced on the cloud, and they must always be subject to continuous streams of check to ensure they're safe from any kind of backup. So what these code scanners will do is they'll run a variety of tools such as code cleaners, hash checkers, even fuzzers in some cases, fuzzy. We can also use SAST scans in deployment pipelines such as Sneak or Sonar to continuously check software before we actually integrate. So I was kind of designing a pipeline over like the course of my internship, and these are some of the tools that I used in like the continuous integration setup to make sure that the code was cleaned up automatically before we integrated and pushed updates. So that's kind of like something you would do in DevOps right there. So onto Cloudflare. A Cloudflare is basically a CDN service that operates on a largely distributed network. So Cloudflare provides like its own set of networks and like subnets that are secured and have their own stuff in place. So Cloudflare improves web app security by serving as a reverse proxy for your web traffic. And normally this would be a server sitting in front of the web servers, like on the back end, and the forwards client's requests. And it moderates that connection between the user and the backend server. So a bit more on uncovering Cloudflare. There are a few tools out there that can help you get historical DNS records. such as security trails right up there. Or you can do something like checking historical SSL certificates that are pointing to the original IP address from a reverse proxy. So it isn't always clear what the backend server is on the reverse proxy because they're not allowed to tell you that information. But using these tools, you can still get it without having to like rely on the reverse proxy in the middle. So from last week, if you find something subject, like a header subject to an SSRF, you can use that inside of the web application and abuse it to obtain the IP addresses of the original web server that can help you circumvent that reverse proxy, and thus any security protocols that the reverse proxy might have set up for you. And if you have a set of potential IPs where the web page is, you can use the tool Hack Origin Finder, and that was found on Hacktricks. So this is an example of a use case for Hack Origin Finder. You can use the tool's Prips to check if the tool is working. Prips is a little similar to Ping, but gives you a little more of a detailed summary. And then you can, if the company you know is using like AWS Webpacks, you can use the previous tool to search the web page inside of the EC2 IPs and be able to find the domain around. When basically you circumvent the reverse proxy that's control set up, and you can establish a connection with the test as well. So that can be pretty big, and anything that might use, say, Cloudflare is a middleman. So now a bit on CI/CD pipeline security. So a bit of an overview on CI/CD for those who don't know. CI stands for continuous integration. So it's simply like an automation that allows us to automatically test code before we integrate it or like say, make a merge into like a branch. So it's able to like say, well, if I have some sort of faulty code that's say susceptible to a fuzzing attack, then a CI platform like Circle CI or Travis CI will be able to like scan the code against a database of like known code patterns and be able to figure out that like this code pattern is susceptible to say a fuzz attack or whatnot. So we could use code CI tools and like SAST scanners within that workflow to be able to find that. The other part is continuous deployment. And this is a workflow to automatically push the completed products over to the right parts. So you define like a set of like rule engines or whatnot to like define like what is the target deployment of this completed package and how are we exactly going to package and distribute them to the right people. So that's continuous deployment, continuous integration. So what exactly could go wrong? We're going to focus a bit more on the CD part for this one. So suppose that our code passed all the checks during CI. And it's properly integrated. Afterwards, a CD pipeline would generate an artifact. And the artifact is simply like a nice package of the compiled build scripts and the dependency information that comes with the software file. So it's kind of like the finished package in a way. So the workflow will place everything into that artifact. And now what happens if I want to transmit that artifact across another workflow or another build? So if a dependent process needs that artifact to run a series of checks, I would need to transfer that artifact into another workflow. And you have transmission space in the middle, so there are some things that could go wrong in that transmission space. One such thing is artifact poisoning. So this is simply the alteration or modification of software artifacts between the transmission between workflows. So almost exactly a year ago, in December 1st, 2022, the Rust programming itself came under an attack based on artifact poisoning. So anytime you have an artifact that has been transmitted across multiple different workflows, you have to make sure it's sanitized. In the following slides, I'm going to talk a little bit more about like the exact Rust vulnerability that happened. But the basic thing is within the main like ci.yaml file that defined the workflow for like the steps to process the artifact and push it into like the CD pipeline, we had this piece of code. Now, can anyone tell me what's wrong with this YAML file? I know it's a lot, but what do you think is kind of off about it? Yeah.
So I don't fully understand this, maybe I'm wrong, but can you have two different artifacts that are both libgcc JIT?
Bingo. That's actually a big point. So that first part of the YAML file downloads the libgcc.jit.so. That's our artifact in question. And it downloads the file from Antoyo/GCC repository. So it's gonna check if the artifact is there, and if it's there, it's gonna straight up down. That's kind of the basis of what the first part of that does. Afterwards, the YAML is going to set the appropriate environment paths for the library on the user system. So it's gonna take up all of that like artifacts, it's gonna build it, and it's gonna set like the library paths based on like the place where you uploaded like the GCC compiler, and set that through echo it onto your GitHub environment. So it's gonna be on your computer. Now there's a slight problem with that, and that's that this does not distinguish the master repo from forked versions. That's kind of a big deal, don't you think? So yes, it turns out that the one in the forked version will be completely treated the same as the one in the master version. And that was a very big deal, because it turns out to poison this artifact, what I'm gonna do is simply make a fork of the main YAML file from antoyo./gcc's master. So I'm gonna call it fork antoyo gcc. Now, what the workflow is gonna do is it's gonna get the artifact via the workflow from this repository and look at the GitHub artifact storage on the cloud. That's the first thing that should happen. Now, what happens when we do the fork? We're going to, the main repository is going to attempt to put the artifact into the workflow, but because we forked the repository, it's going to put the same artifact via the same workflow, via the same repository that you forked from into the GitHub artifact storage on the cloud. And it's going to intercept that before the main workflow will put the artifact from the legitimate artifact into two. So it's going to read from the forked file. Now this is bad because apart from the forked like repository, I could keep everything else constant except for the artifact itself. I could say add a little more extra code and like say have it leak your GitHub credentials or whatnot while it's still being built. And the thing is that the GitHub Actions workflow does not need to see that because it considers the artifact as good at this moment. So it's going to run the malicious code kind of as like a Trojan horse. So the latest artifact that has been forked into the repo is returned, and it's read into the CI YAML file so that the bad artifact is integrated and then deployed across all the inputs. This caused a lot of damages for anyone who is using Rust at the instance. So like this is a pretty serious vulnerability. So how can we possibly mitigate it? We could use the tool known as cosign, which is another tool chain and standard for signing and verifying and assuring software integrity based on something that you add. So given a pack to the artifact registry, such as like the GitHub artifact registry we were talking about before, we can upload a signature to the registry. And that would look something like this SHA-256 hash. So that's directly connected to the artifact. So by signing artifacts before uploading them to the registry, you can guarantee that the artifacts are not tampered with after they've been uploaded, right? Well, as it turns out, unfortunately, it's not Joker. Along with co-signing, you can also tag artifacts for release based on a certain version. For example, if I'm using like a different GCC compiled version, what if I want to revert to version 1 or version 2? So what we're going to do is we're going to tag the artifacts under some version 1.1 image and then invoke cosign on the image version 1.1 to sign it. However, that's a big problem. It turns out that a malicious actor could still add a malicious artifact to the registry and make you sign it before the workflow is complete. So how do we do that? We're going to add an artifact v1.1 stored in the registry. That's the first thing that's going to happen in the workflow. And a malicious actor with access to the registry could upload a fake artifact. Namely, it's going to upload it to the path image v1.1. And then afterwards, the signing workflow is going to be invoked. So cosign sign is going to be invoked. However, because it's reading from the image v1.1 path, I simply have to upload a fake artifact into that path. But by then, the cosign is going to look at that fake artifact and then sign. So a new SHA-256 hash is created, but it's the fake artifact. So when CI/CD uses cosign sign to create the artifacts and then cosign verify to verify the artifacts with a private key, of course it's going to work. It's as if you just use the same artifact and put it through, but it's not actually reading the contents of the artifact. It cannot tell the image in the path v1.1 being bad or being good. So using a simple tag is not enough. And it turns out that we could still have artifacts even with the strategy. Does anyone have any questions? That was a little.
So just because I don't fully understand, do you have to do this right before it's being deployed, or can you just do this whenever?
The problem is if you don't put the path to the image in 1.1 before it's gonna be deployed, then it's gonna read the legit artifact that has been uploaded from the right, right? So in that case, then the SHA-256 sum hash is valid. So you'd have to do kind of like the previous step of creating the fork repo, but because that was the most recent pull request, it's gonna read through that first. So it's gonna get the bad artifact under that path first. That's kind of like the basic workflow of what would happen with the artifact. So it's going to sign the bad artifact and verify the bad, is kind of what's happening. And we don't want to do. So the final solution is instead of using tags and putting it into a path, we can instead use a digest. So a digest is another hash that's specifically run once you unpack the contents of the artifact. So once we unpack the contents of like the SO file containing the build data, we'll run like a tag on that real image to get the digest. So you can see on that line, we run like Docker tag image for the latest real registry image. And then that digest is taken because they map directly to the image. So every single image itself, based on the code that it has, will be mapped to a unique digest. So when we try to do the same workflow we had before, it wouldn't work because the bad artifact has a different digest itself from the actual good. So that's what's going to happen. Then we could simply sign the good image with our private key and put it under the real registry. So that way we kind of solve the problem with artifacts. There's obviously way more stuff like hash poisoning and other things that can happen, but unfortunately I don't have that much time to talk about it. So a few resources for any CloudSec testing or say challenges with cloud security. You can use Hacktricks Cloud. That has an extremely extensive resources and like known database exploits that you could be found. Speaking of database exploits, ExploitDB has a few things on like insecure headers and stuff in Cloudflare that you can use. And then I use those blog posts to talk about like the artifact poisoning part that happened. So legit security has a lot of good other blog posts that cover multiple things. You kind of have to do research when doing cloud security. A lot of it has to do with like what has previously been found and hasn't been fixed. So it's kind of all. There's no next meetings. Good luck on finals, everyone. I hope you guys have a great weekend.